And I will introduce our first presenter, Brenna Meade. Brenna Meade started working on campus networking for Colorado State University as an undergrad and grad student. She then became a network engineer for the University of Denver in Colorado. In 2019, she began working for Arapahoe County government as a senior network engineer, designing, implementing, and supporting county networks. Brenna is currently a network system analyst for the international network teams at Indiana University. So Brenna, I will let you continue from here.
Perfect, thanks, Jorge. Let me go ahead and share my screen. Everyone can see my screen?
Looks good, Brenna.
Looks good.
Perfect. Well, hi, everyone. Again, my name is Brenna Meade. I'm with International Networks at Indiana University and EPOC. EPOC is a partner for this workshop. And today I'm going to talk about BGP and R&E networks. So we're going to go over some basics of BGP and how R&E networks differ from commodity networks and some of the networks that those of us are used to at our homes or at other businesses. And then later today, Hans Adelman, also from the EPOC team, will go over BGP security. So today is a day of BGP, so get ready and we'll get started. So today I'm just going to go over what EPOC is, a BGP overview, R&E routing, why it's different and why it matters, mechanisms for steering BGP, and a real world example. And then at the end, I'll leave some time for questions and discussion, as that was some of the feedback from last week, more time for some questions. So if anyone has questions, feel free to put them in the chat or save them till the end and we can have a discussion at the end. So EPOC Engagement and Performance Operations Center, it's a joint project between Indiana University and ESNet. So we create partnerships with regional infrastructure and science communities that span the NSF and DOE. So we have 5 focus areas: roadside assistance, consultation, application deep dives, network analysis, services in a box, DMZs, personas, etc., and training. So today we'll be focusing a little bit on that training section and also going over routing within the R&E community. So we're going to start out with what is BGP? BGP, or the Border Gateway Protocol, is a protocol used between routers to exchange information and reachability information between or inside ASs on the network, so on the internet. So BGP makes the internet work. I know that seems ridiculous as an overarching statement, but it is true. And in most cases, it just works. However, we find in many cases, especially in R&E, that it needs to be tuned for the best performance. BGP makes routing decisions based on paths, network policies, rule sets, etc. Later, we are going to go over how BGP makes those routing decisions and how you can tune your BGP to perform the best for your data transfers or for whatever type of network needs and use cases you have. Something else that's important to know as you talk about BGP is the AS number. AS stands for Autonomous System. It's used on the internet to identify networks and systems. It's a collection of prefixes or routes under the control of one or more network operator under one administrative entity with similar common routing policies. So for example, TransPAC, which is run by International Networks at Indiana University, has an AS of 22388. So that is how it's identified within BGP when you use show IP route. It used to be a 2-byte number, however, we needed more, so now it is 4 bytes. In the 90s, we had less than 100K AS numbers on the internet, and now we have over 100K. Some of these spaces are reserved for private use, and as time goes on, we expect more and more AS numbers to start appearing on the internet. So I spoke earlier, we have R&E networks versus commodities. So many of us know what a commodity network is. It's the internet used for a company or a business. It's your internet service provider. it is Google, it is Amazon. Instead of commodity, we also have R&E networks. So that would be things like your regional network. Many of you are from universities that connect to a regional network, whether that's GPN, FRGP, iLight, NYSERNET, Internet 2, ESNet, GÉANT, which is the network connectivity for European science networks, and then also European NREN. So all of these fall under the larger umbrella of R&E networking. And there are differences. There are many commodity networks, and there's many research and education networks, but they have separate purposes and different tuning that can be done for better performance. So what makes our RNE architecture different? RNE networks are engineered specifically for science traffic. We want to keep RNE traffic on RNE paths if possible because they traditionally have higher bandwidth, performance engineering to create the best possible data transfer performance. And we determine the behavior of these routes, and making performance better on RNE paths than often on commodity routes. In order to have the best performance on RNE networks, we all have to do our parts. All routing decisions have to be made locally and with intention, and emergent behavior is also important. So noticing what happens in reality versus what we expected routing to do. So what do we do? On a high level, we need to use BGP policy to keep RNE traffic on RNE networks. So we do this through BGP announcements to attract traffic. Routing determines the path the traffic takes through the network. BGP gives us the tools to determine that path. BGP is a path vector protocol. So the shorter AS path is preferred. And I will have a diagram in a few slides to make this concept a little bit more clear. But as with many things in life, the internet is going to choose the shortest path naturally. If AS path length is the same, then other criteria are used. And later we will go over the BGP path selection algorithm and go over how some of those other decisions are made when AS path length is the same. In order to do some performance tuning, it's often necessary that we have to override BGP's use of AS path length when choosing between RNE and commodity paths. Often, the path length algorithm will choose a shorter path that includes commodity over the better performing high bandwidth RNE path. In most cases, the RNE path is longer. So based on just AS path length, BGP and the internet will try to choose the commodity route. So remember, hop count is a legacy metric. And so some of the things that we're going to go into as this presentation progresses will be how to tune that legacy metric to work in your favor. So why does this matter? This example is from the Ohio Supercomputing Center to NERSC. So these are very common data transfers between the Supercomputing Center and NERSC. And the EPOC Center was seeing very slow performance on data transfers between these two locations, below 60 megabits per second. We were expecting to see closer to 10 gigs, so 60 megabits per second is very poor performance. It turned out after a little bit of engineering and deep diving into BGP policy, an out-of-date BGP policy was causing traffic to pass over the commodity instead of the RNE paths, going both directions. So sometimes we'll see in cases that a route is asymmetrical. So in one direction, it will take the RNE path, and in the other direction, it will come back the commodity, which does also affect performance. But in this case, it was taking the commodity path in both directions, significantly deteriorating the performance that we expected to see between these two data transfers. Commodity networks often throttle high-speed flows. In the world of Comcast and CenturyLink, a large significant traffic spike means a DDoS attack. But in RNE, it just means that scientists are doing what they're expected to be doing, transferring data between each other at high capacity and high bandwidth. So what's next? In order to control BGP, we need to know how to manage it. So BGP just works, but as I said earlier, it needs to be tuned for best performance. Best path selection is a 10-step process, or can be. So I'm going to go over 4 common steering mechanisms today, but also to the right is some other steering mechanisms that are used that I won't be discussing. So we have AS path, origin type, MED, eBGP, IBGP, which we will go over a little bit in the hands-on exercises coming up, network exit, age of route, router ID, and neighbor IP. So these are many of the ways that we can steer BGP for best performance, but we're just going to go over local prep, communities, AS padding, and MEDs. So the first way that in BGP we can help the network choose the RNE path is local preference. So this is per prefix in BGP. It modifies the path for your outbound traffic. So if you change your local preference to higher than another, then it will choose that path. So in this example, the local preference for the commodity network is 100. And we set the local preference for the RNE network at 200, meaning this traffic will take the RNE network because of that change in prefix or addition. An additional way that's becoming fairly popular throughout, especially in the RNE community, as these networks grow and become more performant, is BGP Community Strings. So a community string is a number. It's almost like a tag. So we're tagging these prefixes with communities, telling the peers how to handle the prefixes in a special way. So this allows us to make changes to routing policy based on the per prefix strings. And prefixes can have multiple community strings, just like anything can have multiple tags. It just provides information about that prefix and what decisions should be made based upon that community string. Communities that might be useful to external networks should be public. So this provides a mechanism for peers to affect a network's internal behavior. Some common uses are changing their local preference or DDoS mitigation. So what you want to do as a network engineer working with BGP is look for upstream network published communities. So that may be regional or national. We're going to go over some of the community strings that Internet 2 uses in order to give us more information as routing decisions are made. So for example, public BGP community strings offered by Internet 2. If you click this link, the slides are available on the agenda. There are quite a few more listed BGP community strings. I just decided to pull these out as examples. So set local pref on your advertised prefixes. So the default is 100. So in this example, 40 is low and then 160 is high. And the prefix identification, so we have our ASN and then we have 5004, which is Amazon. You can also add where does the prefix enter the network. So for this network, it's 242, New York. You can also use it to indicate emergency. So here we have 911, which would discard all the traffic destined to that prefix. We will later go over AS padding, but this is another example, is you can prepend your prefix to make your path longer using these community strings. So as I mentioned earlier, AS path is a legacy metric. So it's how BGP usually just makes the internet work. So as you can see from this diagram, BGP and the normal workings of the internet are going to go from campus 1 to campus 2. Because this AS path length is 3, they're going to want to take this commodity provider, which is only 10 gig, and again has some of those commodity settings that will affect your data transfer performance, such as DDoS mitigation and window sizing and jumbo frames. So we want to take this path, which is again longer, but has higher bandwidth, 100 gig connectivity throughout the regional 1, internet 2, back to the regional 2, and then over to campus 2. And so in the next slide, we'll show you how to sort of mitigate this using AS padding. So again, BGP will choose the shortest path. So something you can do is AS padding, which essentially just adds more prefixes to your path so that it picks, so that it doesn't pick a certain path over the path that has the shortest. So in this example, you can see we added this ASN 133465 3 more times to make the path longer so that this is no longer the preferred path. Multi-exit discriminator is another way that we can help BGP make decisions. So this is useful when you have N+1 connections in your network. It's an indication to external peers of the preferred path in your network. And again, the lowest number is preferred for this case as well. So by doing this, you're indicating that this regional one over here is your preferred path into the network, just by setting these two figures. So what are the takeaways of this BGP talk? Routing will not take care of itself. Yes, BGP just works. In most instances, especially over commodity networks, BGP just works and it does what you need to do to surf the internet or be productive on the internet. However, in R&E networks, it doesn't always perform as expected because R&E networks are tuned to perform for data transfers specifically for science use cases. So often old routes that have been there for years may not work well with new networks as new networks come up or are changed based on changes in equipment or increases in bandwidth connectivity. In addition, we've seen throughout the R&E and international community that often new routes may not work as planned, meaning that BGP does not adjust in the way that you expect to a new route or a new link on your R&E network or even overseas or wherever this new link may be. So something that we as an R&E community are trying to address is how do we address routing and performance as a community and have more efficient and better routing throughout the world. And so one of the initiatives that we have done recently is called the Routing Working Group, which is a collaboration of both domestic here in the United States and international NRENs and other partners to come together monthly and discuss ways to deal with routing issues and also to discuss best practices for BGP and other concepts within the routing community. So we have an engineering focus. We document possible erroneous or interesting routes throughout the world. We identify teams to address them, and then we check in together as a group to work through them. We have about 150 partners within this group, and we have over 15 cases of erroneous routes that we've worked on since the beginning of the Routing Working Group. Within this, as I mentioned, we are also looking to create some best practices for the R&E and international community. So this is a policy focus. Better detailing of policies, routing policies for paths, including preferred backup paths, verify if the policy is being followed, and also create best practices for policies going forward. Some of the examples of routing issues that we've seen within the Routing Working Group are asymmetrical routing, which I touched on a bit, meaning a source to a destination takes one path one way and takes a different path when it returns to the source. I mentioned this is often an issue in the R&E community, as in one direction it takes the expected performant R&E route, and then on the way back it takes the commodity route, affecting the performance of that data transfer coming back to the source. Another example of cases we've seen is R&E data takes a less efficient route around the world, affecting performance. So Europe to Asia routes traversing the US instead of going directly towards each other, Africa to Europe routes traversing the US. Often these aren't necessarily bad. It's just important to confirm that the BGP again is working the way that you think it's configured to work, and just monitoring those BGP selections as they change throughout the world. Again, R&E taking a commodity route when an R&E path is available, and then new R&E links are removed or added, but routing does not adjust appropriately. So again, some of the goals for this routing working group in 2022, especially regarding BGP, is to introduce more routing cases and solve more routing anomalies throughout the world. Continue to provide tool talks, similar to some of those that you've seen at this workshop, and create a series of community-driven BGP best practice documents. So best practices for R&E providers specifically, and how do they differ from other networks? We touched on that quite a bit in this talk. Scalability, how do we scale up effectively and without affecting performance? Load balancing, R&E peering agreement best practices, and again, communities, how to use these with a focus on R&E networking. So if any of you have any questions about this presentation, BGP, would like BGP resources, or are interested in joining the routing working group, feel free. Two of the chairs are here on this, this class today, Hans Adelman and myself, Brenna Meade, and our emails are there. You can join the routing working group and you'll get on the routing working group list and be added to the monthly meetings where we discuss cases and where you can bring your own cases to be discussed by the community, or ask any questions that may be impacting you at your home institution. We also provide tool talks. Our next meeting will be a perf sonar tutorial based specifically on routing troubleshooting. So if that interests any of you who were in the perf sonar talk last week and would like to see how it's used to troubleshoot specific cases, feel free to contact us and we will get you added to the routing working group. Okay, and I would like to open us up for questions. If there are any, there may be some in the chat, so I will take a look quickly here.
There have been a few. I've been trying to answer them as they come in. The last one is from Michael Smith. He asks, are community strings in BGP similar to S&P community strings? And honestly, no, they're not, is my answer. So, and security is very different for both, Brenna, if you want to.
Yes, no, they are not. S&P community strings aren't really an identifier of a decision or what might happen along that path. You know, S&P community strings are just so that two devices can connect to each other and read information of each other or write to them. And that's not exactly what BGP community strings are. And I think Hans will touch a little bit on community strings in his security talk as well, but they are not the same.
And of course, if you have more questions, Brenna will be in the BGP breakout session after the first lab.
Yes, and I will also be here for the hands-on exercises in case any questions come up as you all work on it hands-on.
The question from Paul is, so is the combination of all these knobs more of an art or science, Brenna?
I think it's, you know, in my opinion, it's more of an art. I think, especially in the R&E community, a lot of it is trial and error. Wow, this performance is not what we expected. What's happening? What's causing that? We have this science use case and we're expecting X performance, X gigs out of it, and we're only getting, again, 60 megabits per second, like that Ohio State example. And in essence, you know, it is a science because we are network engineers, but a lot of it is an art of what's the best path. What is the best option to change how this BGP decision is made? Is it AS padding? Is it community strings? Is it some combination of all of these systems to make peering better? And also, it takes a lot to actually see the problem and identify whether it's asymmetrical routing, traffic going over commodity link, traffic taking a route that you're just not expecting there, or that isn't performant. So it's, I would say, an art. And as we get better at it, and we develop these best practices that I spoke about the routing working group, we're hoping to push it more towards a science where we sort of all know exactly, not exactly, but have an idea of what the ultimate goal is and the best practices are with BGP. But again, Because BGP just works most of the time, it lands sort of in the back of the head of many engineers. Well, the traffic got there, but it's sort of an art to see how it got there and whether that's the best performance it can get.
Michael asks, if our institution is not part of an R&E network, how do you apply? And I believe, Michael, you're Fayetteville. So you would want to contact the folks at the MCNC regional network. They're the ones that support North Carolina. And we can, of course, get you in contact with them. Oh, nope, never mind. Sorry, I Googled the wrong FT. Oh, good, perfect. I Googled the wrong FTCC.
Okay. Yes, we'll have
North Carolina.
And then we'll
Thanks,
be
Adair.
covering route maps and route filtering with BGP in this session. I don't know about the hands-on session, but it's certainly something we could talk about in the breakout group, in the breakout session, if that's a topic of interest to those in the group.
Yeah, Brenna, and we will be covering a little bit of that in the hands-on session.
Perfect. Yes. Okay, well, I have 2 minutes left if there's any more questions. Hans, will you put my email in the chat just for contact info? And
Sure will, yeah.
thank you everyone for joining my presentation. And if you have any questions, feel free to email me, join the routing working group, or just put them in chat as the day goes along. And I'll be here all day.
Thank you very much, Brenna.